In today's class, we're going to continue our discussion about content providers and various ways to implement them and program them, talk about some of the supporting infrastructure that they have. And we're going to start by talking about how you use content resolvers in order to program to content providers, program application access to content that's provided or managed by a content provider. As soon as we're done with this, then we're going to turn around and talk more about how do you implement a content provider, and we'll talk about both sort of the design issues as well as the implementation issues, and I'll show you a bunch of examples there as well. Okay, so what we're going to do in order to make this discussion as concrete as possible is we're going to talk about how we're going to do this. Make sure this is working. I think it is. How this is going to be working in the context of a simple example. This example is going to be used to access the elements of your contacts database that's on the phone. So this particular example will basically dump out the contents of your contacts, and in this case just the names, but you could have it dump other things out as well. So the content provider for contacts, which is called the contacts provider, basically gives you a way to do a whole bunch of different things with information about your friends and family that are stored on your Android device. And there's a bunch of different pieces here, so I'm going to give you a little bit of overview of how it kind of works. It's very complicated, and then we'll talk about how you could write some applications to program it, to query it, insert, delete, update, all those kinds of things. So the first thing is there's this concept in Android in the contacts content provider, which is called a raw contact. And that is basically a person's data that's coming from a particular source. Nowadays, you actually probably have multiple ways of identifying yourself. You might have your Gmail account. You might have other information like Facebook or Yahoo or other ways of describing yourself. And each of those things correspond to what's called a raw contact. And the contact provider allows you to take all those different raw contacts and kind of roll them together to form a cooked contact or an aggregate contact, which is basically the contact information that could identify multiple facets of an individual person and all the different accounts that they have and so on and so forth. There's a number of different tables that are used internally by the content provider. These, of course, are implemented with SQL and SQLite. And so here's some of them. There's this thing called the contacts contract.contacts, which is a table where the rows represent different contacts, different people, and information about those people. You can take a look at that online. We'll talk more about contracts for content providers later. There's also something called a contacts contract raw contact. And this, again, basically provides a summary of data about a person that are specific to their particular account, to their particular type of user. And then finally, you have these things called the contacts contract data, and that's actually details for a raw contact. So that might be your email address, your phone number, other things along those lines. So those are some of the key tables. If you were to poke around in the implementation of the contacts content provider on Android, which is in Packages, Apps, Contacts, then that's the kind of thing you'd find. It also, as part of this overall mechanism, although this is actually stored someplace else, this is not in Packages, Apps, this is stored in other parts of Android. They have things that correspond to how you identify these particular tables, how you identify the contacts application and the services and capabilities it provides. And they do that in a couple of different ways. We'll come back and look at this several different times. In this contacts contract class, which is down here, the path name to it in Android is down here, you can see that you have this constant called authority, which in this case is com.android.contacts. And then you have the authority URI, which is the content prefix plus the authority, so that's the URI that gets us to the content provider for contacts. And then if you look underneath here, you'll start seeing the various links to the tables that are there underneath the content provider. So for example, here's the URI to the contacts information. And you can see what they're doing is they're basically taking the URI that's defined up here, which is content : com Android contacts, and then they're appending onto it the contacts suffix, which is actually just a piece of the path that will be used later to identify more specific parts of the overall content in the contacts database. So let's take a look at some ways you might program all this stuff using Android from an end user perspective or an end activity perspective. And this is a very, very simple application. It's just going to go in and read all the contents that you have in your contacts and then just throw them up as a giant way of, big array, list view that lists all these things. So here's the contacts list example, which is a list activity. So it makes it possible to display things as a list. As you can see here, you start out by getting your content resolver using the factory method, the singleton factory method that's built in, gets you the content resolver. And then we go ahead and we query this thing. As you can see here, we pass in the content URI, which gets us to the contacts, the content provider portion, the contacts part of that. And then we go ahead and we pass in a string, which we say basically is used as the projection. What that means is, go find me the columns that match this particular name, which in this case is the display name and the username that you would have for the contacts in your contacts list. So that's what we do first. And what that gives us back is a cursor. We'll talk about that in a second. And then once we get the cursor back, then we go ahead and determine what data we want to display, and then we go ahead and display it. So we'll talk about each of those things in turn. Before we talk about that, though, let's quickly talk about what a cursor is. So a cursor is essentially an iterator. Those of you who took CS251 have lots of experience with iterators. We'll talk about the iterator pattern if we have time, probably next on this Wednesday. Before we wrap up, I want to make sure we cover the other stuff first, though. And basically, it gives you a bunch of iterator-like operations. You can move the cursor to the beginning of the list of things that you have. You can move it and step through one at a time. You can going next, 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 move to next, go through there. And you can also go ahead and get information from here. You can get the index of a particular column name. You can get the string that corresponds to what's in there. So you can basically get access to the read-only data that comes back to you from the underlying content provider, which is what populates this cursor as part of the query method. And we'll come back and look at that in more detail. Take a look here for finding out more information about cursors. So in our example, we're going to go ahead and basically say, give me back a cursor that contains all the items that I have in the particular phone list, my phone app, and you get that back as a cursor. By the way, what's the point of having something like a cursor? What benefit does it provide people who are implementing these capabilities as an implementer? Why do you have cursors in a technology like SQLite?
You can get results that are either like just a few results or like millions of results in the same fashion. Like you don't have to use different strategies. Right.
So whether you get back one or many, it looks the same from the user point of view. And another benefit, anybody know another benefit?
You don't have to keep it all in memory at the same time.
Right. So a cursor is an abstraction using the no problem is so hard you can't solve it with enough levels of indirection meta pattern that's popular in computer science. And so the implementation of cursor can have a buffer that'll bring back so many, either a certain number of results or a certain size of the results, and that's shielded, as Sean was just saying, that's shielded from the application developer. The fact that sometimes you may have to go out and grab the next chunk of things from wherever you stashed it away, that's the cursor implementer's problem, not the end user's problem. So it just simplifies access to a potentially arbitrary stream of data. So you can see here that what we do is we go ahead and make a list of strings, which is an array list, and we're going to use these to store the columns that we're interested in, the things that we care about in the data that came back to us. And so what we do here is we go to the very beginning of our cursor, and we loop while there's anything left in the cursor, and we go ahead and add to this list of strings the string that corresponds to the column that is the display name column. So we basically go through and we say, give me the display name result, and we go ahead and stick that into this list of strings. And then the last thing we're going to do is display this thing. And as you can see here, we make ourselves something called an array adapter. And an array adapter basically is a way of being able to take Java objects as input, and it maps this input to something that can be displayed as a text view on the layout. And so underneath the hood, the array adapter uses the toString method to convert the data input into something that can be displayed as a string. And then when we're done with that, we just simply set that as the list adapter on our activity, and that magically corresponds to displaying the results on the screen. And you can read more about the array adapters here. Very, very useful thing to have. That's a very, very, very simple example. We're just getting basically one element and displaying it. There's more sophisticated things that you can do with other mechanisms in Android. So what we're going to do is we're going to enhance the example just a little bit in order to make it do something more sophisticated. And what we're going to do is add another field. We're going to have another column that we're going to be looking at, which is going to be the ID. And we're also going to filter out certain things that we don't want. So we're only going to get stuff that matches the filter. So an example of a more sophisticated query. If you looked really, really carefully here at the example, what you would see is that what we have here, unlike originally where we had just dumped out the name of the person, if you go back here, we just dump the names out. If we go up here, what we end up with is the names and the underlying ID number that Android uses as a way to uniquely identify every row that's in this particular database, in the contacts database. So here's what we do. We go ahead and we create ourselves an array of strings, which are the columns that we care about. And as you can see here, we're going to have the contacts ID and the display name, as well as the starred fields. We're going to use that as what we want to be able to return from our query. And then we go ahead and figure out the columns that we want to actually display, which is a subset of the ones that we're going to query on. And then we create some other things, the column resource IDs, which is basically saying treat these things as strings and ints. In this case, strings and strings. And then we go ahead and get our content resolver and query. If you take a look here, what you can see is we're querying the content provider for contacts through the content URI, which we got from before. We're passing in the columns, which are these three columns, the ID, the display name, and whether or not something is starred or not. Starred is essentially favorites, right? So you may mark certain contacts as starred, like your close friends or your family or whatever. Those are your favorites. We're going to basically filter. We only want to select the people who are not starred. So everybody who's not starred, we're going to select for that. And you can see how we do that by passing in a filter where we say, I want to take the case where starred equals nil or 0. You could change that to 1 if you wanted to be able to return stuff that was your favorites. And then when we're all done, we go ahead and use something called a simple cursor adapter in order to be able to take the results here from the cursor and the layout for how we want the results displayed. And then we give the columns we want to have displayed, which, as you can see, were the ID and the name of the person, as well as the resource IDs, which is kind of the type information for these things. And that goes ahead and then displays the results that we saw before. So that will give us this particular display. So you can see getting a single column or getting a group of columns is really pretty straightforward, more or less the same kind of thing. Fix one thing here before I forget. Any questions about any of that stuff? Okay. Whoops. So. All right, so here now is an example of how we can go ahead and write a function, a method that we can use to delete contacts from the content database that we have. Now, you have to be careful. You may not want to delete your database contacts, so use this carefully. We have a couple of different examples here, one of which goes in and deletes a particular contact by name, and the other which goes in and will delete all the contacts. Obviously, be very careful with that one, right? So here's what you can do. You can come in here and say, basically, delete all the contacts under this particular, delete all the raw contacts with this contact URI. Probably not something you would do without some thought. This example up here allows you to come in here and say, I want to delete a particular contact that has this name, the name that's passed in there. So that'll delete just one that'll delete a contact that matches this particular filter, as opposed to deleting all of them. So again, you can kind of get a feeling for how we use the parameters that are being passed in here. We're giving it a sort of a column name, display name, and then an operation giving it the question mark, which says fill this in with a wildcard, and then we go ahead and we create the appropriate array that contains the name that we want to delete. Here's an example of how we might go ahead and insert some stuff in here. Now, the thing to remember about inserting is that there's a lot of things you have to fill in. So this example is more complicated than we might want to be the case. But basically what you do here is you come in here and you create an array list of content provider ops. Remember, if you think back to what we talked about last time, content provider ops are these operations that can be used to do batch operations. You can do a bunch of them at once. And so we have an array of these things, and then we're going to go ahead and create a new raw contact, which we'll look at in a second. And when we're all done, we're going to go ahead and say, apply this operation to the content provider. Here's the actual way that this stuff works. As again, you can see it's pretty complicated. So we're going to go ahead and insert a new contact. We're going to put the person's account name, account type, and so on. So we go ahead and build that as an operation to build a raw contact. And then we go ahead and make another thing where we go ahead and add some additional information in there, like their contact ID and so on, and we build all that stuff. And once we build up that contact, then that goes ahead and gets inserted. So just showing the more complex nature of how these things work and how we might use the apply batch operation to do a bunch of things atomically or simultaneously. Okay, so to kind of summarize this particular discussion, the Android contact provider gives you a whole lot of capability that you can use to manage the people that you keep in contact with. In fact, on most Android phones, this is actually accessed through something called the People application. Sometimes it's called Contacts, but it's often just called People. And not surprisingly, because there's a lot of stuff going on here and a need to integrate lots of different kinds of contacts, raw contacts from different sources, the implementation is rather vast. And there's some parts of it that are over in the frameworks portion. There's some parts of it that are in the contacts app portion, and the whole thing together is what's used to do this. And you can read and write data. If you really want to learn how to do industrial strength use of content providers and accessing it in various ways, that's a good place to look for lots of interesting examples. Okay, any questions about that? So that's kind of how we access content providers using content resolvers from an end user or an applications point of view. Next, what we're going to talk about is how do you implement a content provider. And this is really probably more, I should really call this something like designing and implementing a content provider. Because we're really going to talk both about the design considerations and a little bit about the implementation stuff. But we're not going to show a lot of programming example code till we get to the next section where we actually look at how you do this with an example. So we're going to talk about the steps involved in designing and implementing a content provider. So as with anything, well, not as with everything, but with many things, before asking the question, how do I implement foo, you should first ask yourself the question, do I need to implement foo? And there's certain situations with something like a content provider where it's maybe overkill. So they have a nice discussion in the Android documentation that gives you some criteria to consider before you invest the effort in actually doing all the stuff we're about to talk about. So here are some of the criteria to think about. If you want to be able to have your app be able to expose complex data to other apps. So maybe you want to be able to write some kind of user customizable spell checker or something that'll be used to keep track of frequently used words that may not appear in a spell checker, but you want to be able to have a user-defined word list. So you might want to make that as something that you would expose to other people to use as part of their app. Because after all, that's one of the great things about Android. It makes it possible to write apps that are really collections of components that can be mixed and matched and shared in various ways. That would be one criteria. If you want to be able to have people copy complex data from your app into other apps. So, for example, with the contacts data, you might want to be able to make ways of copying the content and putting it someplace else. If you're going to send it to a friend as like some kind of address book or contacts list. Another common reason why you might want to have a content provider is if you want to be able to provide custom search suggestions using the Android search framework. So there's this thing in Android that's called the quick search box, and you can have custom search capabilities in there where things will give you suggestions or hints or history and so on. And so these are always implemented using content providers, and most apps that are part of Android do this in one way or another. So it's a very common thing to have content providers for apps that will give you information about searching the content. So as an example, you might have a YouTube app on your phone, and it could keep track of videos that you've watched. Or you might have Google Maps on your phone, and it'll keep track of addresses that you visited recently. And so when you go in and start typing, it'll remember what you've had before, and it'll throw those things up as suggestions as you type, so you don't have to do the whole thing. That's a very useful feature to have, and the way you do it is you make a content provider that knows how to respond to the search suggestions, query operations that are passed in various ways, using something called a URI matcher that we're going to talk about in a second. So let's assume, for sake of argument, that we actually want to create a content provider. So then the next steps to consider are what are some of the design alternatives you have to think about in the process of doing this. Well, the first thing you need to think about, or one of the first things you need to think about, is how are you going to actually store the data? So you're going to store it in some kind of simple container like a hash map? Are you going to store it in files? Are you going to store it in SQLite? Are you going to store it in some kind of remote data access facility like Dropbox or something like that that you can get to over the internet? Those are some of the considerations you have to think about as a designer trying to make a decision about how you're going to implement your content provider. Other question is, do you need the data to be persistent? Do you need the data to be cached locally on the phone? Each of those things will influence the choices that you make. The next thing you need to do is figure out how you're going to access this stuff. What's the content URI that you're going to provide? How are you going to break it up with the authority and other things, the path, the particular item of interest, and so on? How are you going to do that? What's the syntax for that, and so on? And then once you've got all this stuff figured out, you're going to go ahead and actually expose these capabilities using directives that are part of the manifest file. So you're going to go ahead and put an element in your manifest file that says, hey, this particular provider is exported and exposed for other things to do. And somewhere along the lines, when you're actually implementing this, you're going to have to subclass from the content provider base class that Android provides. And you'll see lots of examples of how to do that. Another good thing to do is take a look, just search in Android source code for extends content provider, and you'll find lots and lots of cool examples in various places of things that do that, either in packages apps or in packages providers. Now, when you implement a content provider, when you inherit from this, there's a bunch of methods that you're obliged to fill in because they're defined as abstract. Now, you don't necessarily have to implement all of them, but you have to define all of them. And what I mean by that is you don't have to actually make them do anything useful. You could have them simply throw a not implemented exception if there's certain things you just don't want to provide. If you're just providing read-only access to something, then insert and update and delete may be no ops. But you still have to go ahead and subclass and override those methods just so that you can make them do nothing. So here are some of the methods that you have to implement when you define a content provider. The first thing, of course, is onCreate, which is kind of the virtual constructor that's called by the Android framework when it's bringing the content provider into existence, which is typically on its first use. The insert method, which you can well imagine, having looked at content resolvers, is going to be used to put some content into the content variables into whatever you're storing this thing with. Query is used to go ahead and identify a particular table to interrogate. Back cursor that indicates what matched. Update is used to take a table and replace the contents of a row that already exists. It's very important to remember that with the semantics of these things, as a general rule, you shouldn't call update on something until you've actually inserted it in the first place. Now, when you implement a content provider, you can do whatever you want with update. You could go ahead and do it, have it insert something if it wasn't already there. With the SQLite database under the hood, update requires an insert to already have been made. But a content provider, you control what it does. So you could have it insert something if it wasn't there, if that's what you chose to do. And then delete will indicate which table you want to delete something from. And that something, of course, depends on the implementation of delete and how it interprets the URI as to whether it's all of something or just a single piece of something or a subset of something, and so on and so forth. And then the last piece of information is a way of being able to get the MIME type corresponding to a particular URI, which can be used in order to identify how to process the data that comes back. Are you getting it back as a JPEG? Are you getting it back as a TIFF? Are you getting it back as a text file? And so on. And there are various ways of being able to indicate the types of the operations that correspond to those URIs. If you take a close look, you'll see that all the methods that are defined on content provider are essentially the same as are defined on content resolver.
In the project that we're doing now, we're just storing a like path to an image file, and then we use that and get it rather than storing an actual like image inside of the database.
That's right. Yeah, we're going to talk about that in a second. We're going to talk about storing blobs. So what a binary file would be a blob. A blob is an acronym that stands for binary large object. I think they just wanted to have it be the acronym blob, and they came up with a way to make it mean something. So in our case, the images we're downloading are blobs. And we'll talk about this in a second. If you have small blobs, you can, in fact, store them directly in the database. Things like a thumbnail, image, a really short video clip, you could put them in as blobs. Not widely recommended to do that, but it's possible to do that. If you store something as a blob, you can make a call on a cursor to get the blob back directly. The alternative way of doing things is by storing the data in a file and then having a content URI be stored in the database, and then you use that basically to do an indirection to open the file that corresponds to that content URI. And so that's the right way to do this stuff. And we'll talk about that in a second. Another thing you need to do when you define the content provider is figure out its data model, which is just a fancy way of saying, how are you structuring the information and exposing it out to the outside, storing it internally and exposing it to the outside world. So, for example, you might have a user dictionary, or you have a user dictionary that's part of Android that's used to keep track of certain words that you want to designate as being correctly spelled, even though they might not show up in the Webster Thesaurus or something, or the Webster Dictionary. Typically, under the hood, these things are stored in a table-like form with rows and columns, which is one reason why people commonly use SQLite, although that's not required. Just it's an obvious match. And in this particular, in this world of relational exposing of data models, a row corresponds to an instance of some type of data that the provider is going to manage and collect. I'm going to say manages instead of collects. So in this particular case, if we're looking at this particular example, then the row might be the word and the various attributes that we care about for the word. Precompiler, we have it has a certain application ID, a frequency of use, what language it's relevant for, its row in the table, and so on and so forth. And then a column represents an individual piece of data for a particular row when you put rows and columns together. Since if you're more of an object-oriented person than you are a database person, then the way to think about this is the rows more or less correspond to object instances, and the columns correspond to fields or data members in those object instances. So if you have a field, if you have an object or a set of objects, then each row corresponds to an individual object, and each column corresponds to the various fields within that object. The cool thing about the relational model is you can do you can use various query algebra operations on these things to work with rows and columns in various interesting, powerful ways, which is not what you get out of the box with your classic object-oriented objects with their individual fields. Those are encapsulated and hidden in ways that are a little different from a relational database table. Having said that, most people who program these days typically use object relational mapping mechanisms and tools to be able to map from an object view, which is what programmers typically like to see, onto a relational view, which is what typically the databases like to do. And so there's various ORM, object relational mapping tools, that allow you to go back and forth between those different views. And there's typically ways of doing this via annotations, where you can annotate the code, like say the Java code, with special annotation directives which indicate to the underlying object relational database system how to map those things back and forth. So it's pretty cool. You can pretty much completely automate accessing data that's stored persistently in a database while still being able to preserve an object-oriented programming abstraction to the user, which is kind of cool. Once you've figured out the relational, the model of the data that you want to be able to export, then you have to go ahead and figure out how you're going to expose the content URIs. We talked about this a little bit before. Let me give you a little bit more detailed view. So basically, the content URIs are not unlike a URL in the web land, where they basically indicate how to unambiguously find a particular instance or a group of things. And so each content provider method, like insert, update, delete, query, and so on, uses the content URI to figure out which table, which rows, which columns, and so on in order to access. So there's a number of different parts that are involved here. So you have the part that gives you the name of the entire provider, which is called the authority. So here we can see the contacts provider and a contacts application, and the content provider, actually it really should be contacts provider here, is a content provider. And it goes ahead, and when you access it, this part of the URI gets you to the contact provider. And then you can find a particular table by starting to look into the path, which will point to something internal, like this might point to the contacts table. There may be other tables, accounts, calls, and so on and so forth. And then finally, you can identify a particular element in that table as the last piece, which is the ID part, which is optional depending on what type of operation you're trying to do, which identifies a particular row in that table. So now we get down to something very specific. So you can see here, if you kind of back up there, we've got a way to identify the particular content provider, which is in this case is the contact provider, a table, and then finally a row within that table. Now, some parts of this, as we'll see in a second, like the authority, that's actually managed for you by Android. It keeps track of that mapping. That's what's kind of exposed out through the manifest file to get you to the appropriate content provider. But then the other stuff here, like the tables and the rows and so on, those are things that have to be managed automatically by the content provider implementation. So if you write insert, delete, query, and so on, if you write those methods, you're picking that stuff apart and making sense of it and doing things with it. And there's a whole bunch of helper methods that Android provides to simplify that, but that's something that the content provider has to do, the implementation has to do. Any questions about any of that stuff? Then there's also trying to identify these things uniquely. So there's the authority URI, which basically gets you to the content provider. And then for each table, there are going to be the content URI, which gets you to the various tables. So we have the contacts table, we have the accounts table, we have the calls table, lots of different tables of various flavors and forms in the content provider for the contacts app. And that's used under the hood to keep track of all that stuff. And you can go ahead and take a look, if you're curious, at what that looks like in the actual Android implementation. And I highly recommend poking around in this. It's very instructive, if for no other reason, just to give you a sense of how complicated it is. There's some other things that you're often recommended to do if you take a look at the website about how do you program content providers. They have this whole thing about defining a contracts class or a contract class. And it's basically a way to, it's kind of a facade, if you will. It organizes everything together. So it's typically a public final class that has constant definitions for various URIs, like the authority, the content URIs, the column names, the MIME types, any other metadata that may be relevant to trying to create a content provider. It's good to kind of put it in one place. And so it basically is an abstraction, another example of one extra level of indirection makes things better. So if you do this right, you can actually later change the details of how this stuff works internally. But as long as you keep the names identical and the types consistent, then that allows your application programs that are accessing this stuff to remain unchanged, which is a win. So here are some examples. As we'll see when we look at our example app a little bit later, we're going to have something that does this. You start out by doing things like defining column names, which are basically the names you would use to identify the columns and in the SQL databases. You can also define various, fix that. You want to be able to define string constants that the app can use. Fix that when I'm thinking about it. So here's an example where we have these things defined as string constants. So ID and data are the columns that we're going to care about. And then you typically want to make sure that you have an underscore ID string that's used as the unambiguous, unique, monotonically increasing ID for each row in the table. And this is typically specified if you're using SQLite as the mechanism for keeping track of this stuff. It's the ID field is typically of type integer, primary key, auto increment, which means every time you use it, it goes up by 1 automatically. So you have this unique, monotonically increasing number that keeps track of each row individually. And of course, it's a good idea to document this stuff so people know without too much effort what is going on here. And then you often typically want to define various fields, data members for the MIME types. We'll talk about those next. So there's this getType method that the content provider uses, and it returns a string in MIME format that explains to the caller what the type is of the URI that was referenced in the call to getType. So you can see here you call getType, you pass in a URI, and it gives you back a string. And there are typically a couple of different variants here, one of which is the item, which is used to indicate a single record or a single row in the database. And then there's also this thing called the dir. And the dir is basically a group of records. So you can think of a dir as like a subdirectory. If you have a subdirectory, you could have those contents be a bunch of items. And so it's kind of this whole part approach, or this one many kind of thing. So these, of course, are MIME types. So we have a MIME, right? I had fun trying to find a freely available rendition of a MIME, and the Lego MIME was the only one I could really find. So there's a Lego MIME. So basically, it should return it in whatever is the vendor-specific format for the MIME type. For example, if we have our content provider be com.example.app.provider, a rather uninspired name, but if that was the name of it, here's how it could expose the MIME types. So if you want to be able to get back multiple rows in a table, then you would go ahead and use the dir suffix here. If you wanted to be able to give back a single row from the table, then you use the item field. And that'll give you back the various parts here. That's the way you express these things. And if you look back over here, you can see here's how we set this stuff up to indicate the content type for single items, the content type for multiple items. If your content provider exposes files, then you want to also implement this getStreamTypes method, which is going to give you back a string, an array of strings of the MIME types for the files, so you can know what to do with the files that you get back. So it's basically a way to get insight into the type system. And so you can filter on these things in various ways. So if you have a provider that offers various kinds of photos, like for example the contacts provider, it gives you back photos of your friends and so on. It might give them back in different formats, right? So if you call getStreamTypes, it would give you back this filter string. Oh, if you called it with image/star, it'll give you back this array that has image JPEG, image PNG, and image GIF. Those are the things that it supports. If you want to be more specific and ask it a more localized question, then it'll only give you back one thing. So for example, if you came along and said, the JPEG, what's the type for JPEG? You support JPEG, then it would just give back image JPEG. So you can ask sort of more open-ended questions or more specific questions, and it'll come back and tell you about the types that are supported. When you're all done with all this stuff, at long last, then what you can do is you can go ahead and define or expose the provider using the manifest file. So we've already seen the manifest files before. You go ahead and make a directive. You say provider. You give it a name. Like here's the one, for example, from the Android contacts provider. So contacts provider 2, that's the name of this thing, probably a version number in some sense. Here are some of the authorities that can be used by. Notice how the authorities don't list the path portion, just the authority portion. The path portion is something that's handled by the underlying content provider. You have to be the one to come along and figure out how to interpret that data in whatever way your implementation may happen to choose. Oh, let me see. I think I might have. Okay. One of the questions we talked about before was the whole issue of blobs. How do you store binary large objects? So again, there's different points of view on this. It really comes down to how big these things are. Unfortunately, the word big is somewhat subjective. If you take a look, you'll see that over time they've kind of changed what was big in Android. I think what it basically comes down to is how large of a piece of data can you send using the Android binder framework to move things back and forth between processes. How large is the largest binder message? And I think that's about a megabyte or so at this point. So if it's getting too big, don't use blobs. So small binary objects would be things like small icons, a short video clip. Larger things would be, complete movies, big photographs, complete songs, whatever. If you want to listen to the 25-minute version of In-A-Gadda-Da-Vida by Iron Butterfly and be very psychedelic, don't make that a blob, right? That's going to be too big. If it's small, then you can basically go ahead and stick it into the cursor directly. It can be part of the SQL database in the schema. And if that is how you provide it, then you can simply use the getBlob method to get this thing back as a byte array. So you can see here the getBlob method returns to you an array of bytes, and then you can go ahead and do those things directly. So if you had a small image, then you could just get it back and you just turn around and boom, your cursor would return it, you'd use it, you're done. If it's a large piece of data, though, that's not what you want to do. Don't put large data into blobs, is the bottom line. In fact, there's a school of thought, if you poke around enough on Stack Overflow, you'll find a lot of people saying just don't use blobs, they're bad. It's probably a little bit too strong, but think carefully about what you use them for. Small things are fine, bigger things maybe not so good. Maybe like a thumbnail image might be fine, but things that are bigger could be a problem. So what you can do instead is you can basically have this content URI that points to a file in the file system. And if you take a look, there's a method on content resolver called open input stream, and you pass it a URI, as you can see here. And what it'll do is it'll go ahead and open up a stream to access the content that was designated by the URI. So for example, in your example, what you want to do is you want to be able to have the database, the cursor guy, give you back a content URI, which you can then use to go ahead and open the file using the content resolver open input stream, and then you can use that to display the actual result somewhere on the phone display. Any questions about that? Okay, so to kind of summarize this particular discussion, content provider instances manage access to structured data by handling requests from other applications, and eventually things are going to be bubbling down to content resolvers, which under the hood are used to get access to the underlying content provider. Now we're going to talk in the next section when we start talking about kind of optimization techniques, how there's a few slight variations on this that are important, but that's a good way to think about it so far. All right, oops, there was one thing I didn't put in here because I forgot to unhide it. Let me just talk about it briefly. So to simplify programming with URIs, there's this thing that they call the URI matcher class. And you can give it wildcards and other kinds of declarations. And basically, if you're implementing like the query method on a content provider and someone passes you a URI, you can use the URI matcher to figure out what kind of request it is. So some common examples you see used all the time in Android would be things where people want to go ahead and do like a search suggestion query. So if they type in the search suggestion query, which has the URI for the content provider for, say, YouTube or the Google Apps application, Google Maps application, it'll pass in the earlier part to get to the right content provider, and then it'll put the suggest suffix at the end. And when you pass this thing in to the Android URI matcher class, it'll basically figure out which particular type of request the URI is. And then what you typically do when you write your content provider methods like query, you go ahead and switch on the result return from match. So you can see here, this is a very simple example taken from the documentation, but we create a URI matcher object, and then we go ahead and put some stuff into it. Like we go ahead and say, if the com example app provider table 3, if that's what gets passed in here, then this is the number I want you to return. If they pass, and this would be all the contents in the table. If you go ahead and say, I want something that's underneath that particular content, like a row in that table, that returns this one. So when someone types in the query operation and does the URI match method on that URI, then if it gets back this case, then it's all of table 3. If it gets this case, it's just for a single row in table 3, and so on and so forth. And again, if you look at the Android source code, you'll see lots and lots of interesting examples of all this stuff. Let's go take a look, just for fun. Packages, apps, browser, source. All right, let's see, browser. Whoops. Oh, yeah, that's right. That's because it needs to be in provider. There we go. That's better. Browser provider 2. So this is the gigantic, where gigantic is several thousand lines long file that implements the content provider for the browser on an Android phone. And if you go down here and you look for the query method, there's query. You can see it does, first thing it does is URI matcher .match URI. And let's look for search. There we go, searches. So here's searches. Let's see if they do suggestions. Yeah, bookmark suggestions, right? So you're typing in a URL and you want it to go ahead and give you suggestions of things that you may have bookmarked. So you can see it says bookmark suggestions. That's the thing it matched on. If you look at bookmark, come on. There we go, bookmarks suggestions. So that's defined as some number, right? And then you go down here, bookmarks suggestions, and you can see that they created a matcher, and they say anybody who passes you in the search manager.suggest URI path query URI, I want you to return the bookmarks suggestions number, which was 1004, and when someone does the lookup, which is way down here on the URI matcher, this is what I want you to do. Do the suggest query processing. This is going to do the custom search suggestion stuff. So that's an example of when you pass that stuff in, you being the user, and that's done when you do like quick search box operations. It'll go ahead and use the URI matcher to match against that particular URI, find out what the requested activity or action is. You then jump to that case, do the work there. So that's a very, very, very common thing, and it's almost always done in query for complex content providers. Any questions about that? Okay. The last thing I want to cover today is how do we actually program the content provider. So we're going to start today talking about programming a synchronous content provider, and then we're going to go ahead and talk about asynchronous stuff next time. So we're talking about synchronous content providers. That's the easy case because it's all just done very simply. Okay, so this particular content provider is going to basically map IDs to records. So very, very, very simple, just notional, to show you the mechanisms, the mechanics of how things work under the hood. In real life, of course, you'd have much more interesting data types to do all this stuff. Moreover, we're going to use a hash map here just to make it really simple. So it's just going to store things in a hash map. In real life, once again, you of course would be storing these with SQLite, but I didn't want to have to get subverted by that discussion. We're going to implement all the CRUD operations, the query, and create the insert, query, delete, and update, all of which are implemented as Java methods. And we're going to do two-way calls to start off with. So let's go ahead and look at how we might do this. The name of this particular content provider is called MyCP. Boring name, just chosen because it would fit on the slides better than calling it My Content Provider. And as you can see here, it extends content provider. And the first thing it does is it defines the content URI, which is basically this. So this is how you identify this particular content provider. That's its authority name, if you will. And that's how we're going to identify it when we start using things like the manifest file. We then go ahead and set up some other data structures that we need here. We keep track of the ID and data, which are used here to be what we're storing in our database, which, as you'll see in a second, very simple. And we keep track of the columns, column names, and we just have a hash map that is numbers, which is what these IDs are going to be, with some kind of data record, which is, we won't talk about it, just something or other. We then define a couple of MIME type descriptors. One thing that keeps track of the single MIME entry, like a file or an item. The other, which is going to be used to keep track of a collection of these things, like a directory of some kind for groups of items. And now we can take a look at how we might actually implement some of these methods. So we'll start by going ahead and inserting something into the database. So here we have my content provider. The insert method takes a URI and a content values object. We check to see whether or not there's already something with that particular name in the database already. If there is, we don't do anything, because that's the way insert is defined in this particular case. If you want to update something, use update. If there's nothing in there by that name, we go ahead and create a new data record, creating the data, which is, again, not very interesting, but this is what we're going to do. And we then go ahead and stick that thing into the database, where the database is a hash map, and we put the data in under the ID that came along with this. And then we go ahead and we return the URI for that particular item. So we insert this guy and return the new URI. So whoever gets this can now use that for something or other, like querying or other operations. Here's delete. So with delete, you can do a variety of things. In this particular case, we're either going to indicate what record we want to delete, or we're going to delete anything. If we pass in a request ID string that's null, then we're just going to go ahead and iterate through all the items in the database and remove all of them one at a time until it's empty. If somebody wants us to delete a particular item, then we go ahead and create the integer that corresponds to that. And if that integer happens to be in the database, then we go ahead and remove it from the database. Again, just simple operations on hash map kinds of operations and activities. Here's query. So query in this case, again, is relatively simple. What we're going to do is we're going to go ahead and make ourselves a matrix cursor, sort of a two-dimensional cursor. And if somebody has said, I want every element in this, I want a query for everything, by passing in a null for the request ID string, which we're going to get out of the URI as the last path segment. Then what we do is we just go ahead and go through every element in the database, and we add a row in the matrix cursor that contains the particular elements of that item in the HashMap database that gets stored in the cursor. So this is obviously just sticking stuff in there, not trying to be too smart or too clever about how it optimizes. Or if somebody identified a particular element to query for, we'll go ahead and look that item up in the database, and then we'll go ahead and make a single entry in the cursor containing that and only that element. So we add a single cursor, and when we're done, of course, we return the cursor back to the caller, and then they would use some kind of iteration mechanism like we looked at before to move to the first element and then go through it one at a time, extracting the values out. And we'll take a look at how that works in a second. So those are some of the basic operations. We looked at insert, delete, and query. Update could also be added too. Just have to check to see if something's already there and then update its values. Not a complicated thing to do. So here is a simple activity that we're going to implement, which is going to be a list activity. And it's all in one. It's not meant to be sophisticated or clever. It's just a way of almost like a test case to drive the whole thing and make sure it works. So we come along here and we go ahead and create our new content values object, get the content resolver, and then we go ahead and stick all this stuff into the content. We say this is data record 1, this is data record 2, this is data record 3, and so on. So we just have data record 1, record 2, record 3 as strings. And then we go ahead and we insert those things into the table here using the content URI that we defined before. And that should say myCP. Okay. So now we just put a bunch of records into the database. And now we're going to go ahead and delete some records. So we're going to go ahead and delete record 1, because that's the first item. You can see what we did is we took my content URI and we stuck /1. So that identifies the first element. That's the record ID number we're going to delete. So we delete that. We then go ahead and we make a new one. So we're going to make a new update for record 4, and are called record 4. And then we go ahead and we update something in there. We're going to go update the second element to put a new value at that location. So if you printed it out at that point, record 1 would be gone, and record 2 would now be have its value changed to be record 4 as its value. Then finally, we go ahead and query this thing, and that will then be used to get the results back. Any questions about that? By the way, this should be CR. Notice in this case we use our simple cursor adapter to print out the ID and the data. And what it does, if you go back and look here, it's almost impossible to see this. It's rather tiny. It just gives you back the records that were inserted and the values. So record 2 has the value, or row 2 has the value of record 4, and then item 3 has the value of record 3. Okay, I think that, and then this is how we would go ahead and register this stuff and store it as in the manifest file. So we give it a name, we give it the authorities, so my course examples, content providers, myCP, that's the authority, and then .mycontentCP is the name of this thing. I think it's actually myCP. And in this particular case, we're going to have it run in a remote process. All right, the last topic I want to talk about today is kind of an optimization on some of the things that we've looked at so far. So if you take a look at what we've done so far, pretty much every example, and this is true for most of the examples you see with Android, start out by getting an object that's the content resolver. You use a factory method to get back the content resolver, and you pass in the URI, and it gets you back the right content resolver to the right content provider. The problem with this is it's actually relatively expensive in terms of runtime overhead. And what it's doing under the hood is whenever you call these operations like insert, query, update, delete, and so on, it goes through the content URI and maps things down each step along the way, it takes the authority and goes finds the content provider. It takes the other thing and finds that. So there's actually a non-trivial amount of overhead to do all these different steps. And the reason for doing this is that it could differ from call to call. There's no reason why you have to keep passing the same thing in every time. So as a result, it has to keep doing this check every time. So to try to speed things up, or to definitely speed things up, there's another more efficient way to access content providers. And they're called Content Provider Client. So Content Provider Client is a short circuit optimized way to get basically a handle to the content provider. And every time you call this thing, rather than having to go through that lookup process from scratch, it just goes ahead and goes to the same place each time. And the way that you get access to this thing is you go to the content resolver and you give it a URI and you say, hey, please acquire the content provider client for this particular URI. And that comes back as this content provider client object, and then you can make method calls directly on that, and they're much faster. Now, and it'll also use the activator pattern to start things up as needed. So it speeds things up, doesn't have to do the lookup every time. There are a couple of things there. Don't forget to call release, and don't forget to use locks if you access this from multiple threads. So they're not actually thread safe. So you have to be a little careful there. Oops, I already said that. Okay, so let's go ahead and take a look at an example that illustrates how all this stuff works. So this example is almost identical to the one we did before, the only real difference being at the beginning of the thing, rather than starting by looking up the content resolver and just using that for all the other calls, instead what we're going to do first is we're going to go ahead and get the content resolver, and then we're going to use the content resolver to get ourselves the content provider client. So you can see we get our content resolver, and then we say, content resolver, please acquire me the content provider client, and that comes back and we stash that away. Everything else looks pretty much identical to what we had before, with one small exception. And you'll see what that looks like in a second. So everything else here looks the same. We just say CPC for content provider client as opposed to CR for content resolver. Otherwise, it's identical. Da-da-da-da. The one difference is that notice we used the try-catch block here. And because this is Java and not C++, when we're all done, the finally section will get invoked, and we have to explicitly release the content provider client. We have to say, content provider client, let your resources go. And it's a shame that Java doesn't have destructors, because we could make this sort of the resource acquisition is initialization idiom that's used throughout C++ and C# to automatically do this. But you can get more or less the same effect in Java by using a try finally block mechanism with exceptions. So to summarize this discussion, implementing content providers is relatively straightforward. Let me put that in there. Is relatively straightforward. The way to look at this is it's as straightforward as your data model is. If your data model is very sophisticated and the things you're doing are very complicated, like is the case, say, with the browser stuff we were looking at, or in cases like the contacts, that's complicated, so no surprise, those things are big, but the content provider part is fairly straightforward. There are issues, of course, with two-way calls using synchronous operations, because they can block, and the main thread could block for an indeterminate amount of time if you do a big query, for example, or you go across the network. So as a consequence, you probably want to use some of the asynchronous techniques we're going to talk about next, like cursor loaders or async query handlers. Content provider clients are used to optimize performance. However, you have to be careful because they don't automatically release themselves when they're done, and they're not thread safe. So you typically have to call them. What you typically do is you allocate them in the context of a thread and then just access them in that context, and then they work perfectly fine. OK. Any other questions or comments? So what we have left to do next time, well, besides take a quiz, is we're going to talk about the loader manager stuff, cursor loaders. We'll talk about async query handlers. And if we have any time after that, we'll talk about a couple more patterns. The asynchronous completion token pattern, which is nicely used with async query handlers. We'll show some examples of that. Even if we don't talk about the pattern, I'll show you how the pattern is applied to the example I'll cover. And if we have some time, which we probably won't, we can also talk about the iterator pattern. But most of you probably already know that pattern or could learn it very quickly because it's pretty easy to learn. OK, great. So I will see you on Wednesday for the last day of class.